So basically, we're going to be looking at inequalities in one triangle. And what we're going to be doing is looking at a triangle and putting our angles in order from either smallest to greatest or greatest to smallest. We'll put our side lengths in order from smallest to greatest or greatest to smallest. But first, we want to talk about the exterior angle inequality theorem. Exterior means where? Outside. Okay, so the exterior angle, if you remember correctly, we did talk about this before. So if I had angles numbers 1, 2, and 3, which one is my exterior angle? 3. That's the outside. And if you remember correctly, we talked about this one is equal to this one plus that one. That was one of the theorems that we talked about a while ago. But what this theorem says is the exterior angle just kidding. It says exterior angle, right? That erase, my bad. I didn't read my sentence. The measure is what I meant to say of an exterior angle of a triangle is greater than the measure of either of its remote interior angles. Okay, those are some words that we haven't heard in a minute, but we have talked about them. So the measure of an exterior angle, the degrees of an exterior angle, is always going to be greater than the measure of either of its remote interior angles. So what that is saying is this angle right here, the measure of angle 3, is greater than, I'm not using my greater than symbol because it looks like a angle symbol, either this one or this one, the measure of angle 1 or the measure of angle 2. This number, this measure is always going to be bigger than this one and that one, okay? Because it takes this one plus that to equal that. Everybody okay with that? Kind of, sort of. Sure, okay. The example says, list the angles that satisfy the satisfied condition. Justify your reasoning using the exterior angle theorem. Okay, so let's take a look at our picture. I want to know which angles are smaller than angle 1. Okay, which angles are smaller than angle 1? That says the measures are less than the measure of angle 1. So if I look at my picture, does everybody see angle 1 right here? Is that an interior or an exterior angle? Exterior, okay. So what I need to say is, and this one has a little bit more going on to it, but if I'm looking here, my remote interior angles would be this one here. What makes up that one right there? What two numbers? What two numbers am I pointing to? 3 and 4. Okay, and then it's also bigger than this here, which is what other two angles? 5 and 6. So the angles that satisfy this, the ones that are smaller than angle 1, would be angle 3, angle 4, angle 5, and angle 6. Okay. That's just because 3 plus 4 gives me one of my remote interior angles, and 5 plus 6 gives me my other one. Does that make a little bit of sense, kind of, sort of? One is our exterior angle. If we want to be smaller than that. All right, the next one says a measure that is greater than angle 8. Where is angle 8? Inside my triangle or outside my triangle? Inside. So what I want to know is which angle is this a remote interior angle to? Okay, first of all, how many exterior angles do you see in my picture? 2. What numbers are they? 1 and 2. Okay. Now, although it looks like angle 1 is bigger than 8, I don't have enough information to say 1 is bigger than 8 because they're right next to each other. However, isn't 2 the exterior angle to this being its remote interior? So this means that 2 has to be bigger than 8, just like we said right here, that 3 is bigger than 1 or 2. Okay, so the only angle in this picture that we guarantee angle 8 is bigger than is angle 2. I can't guarantee, even though it looks like it's bigger than some of the other ones, I don't know enough information to determine that. So angle 2 is the only one that I can guarantee that is bigger than 8. Does that make kind of a little bit of sense, sort of? All right, I want you to try the same thing for the next two. Look at the new picture. Tell me what angles have to be less than angle 1. Okay, looking at your picture, name the numbered angles that we know have to be less than angle 1. Angle 1 is here. It is on the outside of my triangle. Let me do something for you real quick. I want to cover this up right now because there are actually two different triangles here. So looking at that, now that I have that covered up, which two angles that I didn't cover have to be smaller than 1? 4 and 6. Yes, those are my two remote interior angles. So angle 4 and angle 6. Now, let's forget about these. What other angles would have to be smaller than 1? I'm not sure. 5 looks like it is, but I don't know enough information. It's right next to it, so I can't guarantee that. What else? Yep, angle 7 and angle 3, because those are away from my exterior angle on the outside. And then tell me which one has to be greater than 7. Or, there's one more. 1. It could be either angle 2 or angle 1 in this case, because 7 is a remote interior angle for both. Everybody kind of okay with that one? I know that one can be kind of tricky, especially with a lot of stuff going on in our pictures. On the back, this is our angle side relationship theorems, okay? In this one, if one side of a triangle is longer than another side, then the angle across from, or opposite, the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Let me show you what I mean. So if one side of a triangle is longer than another side, the angle opposite the longer side is going to be larger than the angle opposite the shorter side. So let's say I give you a triangle with those side lengths. Okay, is everybody looking? What's the longest side? AC, it's 9, okay? So what this theorem is saying is the angle across from this segment, what angle is directly across the triangle in this segment? B is going to be greater than, let's pick a side. This is smaller than 9, right? So what this theorem is saying, I'm trying to get a different color. If I'm comparing segment AC, I'm sorry, kidding. If I'm comparing angle B to angle A, okay, angle B to angle A, here's B. The side across from B is how much? 9. And then here's angle A. What's the length of the side across from angle A? 7. What's bigger, 9 or 7? 9. So what that means is B is going to be greater than A because it is across from a larger side. Think about this. My palms are making an angle, correct? My segment is between my fingertips. Imagine there's a line here. The bigger my angle, what happens to that side? It gets what? In between my fingers, it gets longer, right? The smaller the angle, the shorter that side gets. So we're going to start comparing sides and angles, and it's based off of the opposite. If you're comparing angles, you're looking at the opposite side. If you're comparing sides, you're looking at the opposite angle. Okay. The next one says, if one angle of a triangle, this is backwards, has a greater measure than another angle, then the side opposite that angle with the greater measure, I can spell, is longer than the side opposite the angle with the smaller measure. So in this case, I would want to compare segment AC to segment AB. Okay. I would want to compare, is AC longer than or shorter than AB? Okay, look at AC. What angle is across from it again? B. And how many degrees is that? 40. Okay. And then AB, what angle is across from it? C, which is 70. So would AC be smaller than or greater than AB? Is the angle across from AC smaller than or bigger than the angle across from? It's smaller than, right? So that would be less than. Kind of makes sense? Somewhat, sort of. All right, let's take a look at our first picture. It says, list the angles of triangle LMN in order from smallest to largest. What I want you to do is look at your triangle. Look at your side lengths. Pick out the smallest side. Okay, which number has the smallest side length? MN. Okay, so your smallest angle is going to be the angle that is directly across the triangle from MN. Again, MN is my smallest. Okay, because 5.4 is smaller than 6.1 or 9.5. What angle is directly across the triangle from that? L. Okay, so angle L is going to be my smallest angle. What side length comes next in line in order, 6.1 or 9.5? 6.1, okay. So this is my next one. What angle is directly across from it? N. So angle N would be next. Which leaves what is the last angle as my biggest one? So find the shortest side. The angle directly across from that in my triangle is going to be the smallest angle. Then you find the middle side. That's going to be the middle angle, the angle across from it. And then the longest side, the angle across from it, is going to be the largest angle. Try the same thing for the next example. Give me my angles in order from smallest to largest. What is my smallest side length there? 3.7. So again, I'm looking at the side or the angle directly across from that. What's the angle directly across from that? B. Okay, so angle B comes first. Then what's the medium length side? 4.8. And what is across from that? C. And then the last one would have to be A, the only angle left, right? We said B, we said C, the only one left is A. And we can do exactly the same thing if I have the angle measures. I can say which segments are smallest to largest. So let's take a look at our next picture. First of all, let's focus on our triangle. What two angle measures do I have there? 90 and 51. Can I figure out what X is? How? Yeah. So you got 141 by doing what, 90 plus 51? Subtract that from 180. What do we get? 39? Does everybody agree with me there? Okay. All right. So now we're going to just work a little bit backwards. We want to go from shortest to longest. What is my smallest angle? 39. So if I'm looking at that angle, what is the side? How do I name the side directly across from that? WY. So segment WY is the shortest. What angle is the next one in length or in measure? 51. Okay, so we're going to go directly across from that. How do I name that side? Y, X, X, Y. The order of the letters doesn't matter as long as you have an X and a Y there. And then what's the only other side I haven't named in my picture? WX, yeah. And then you have that little tip there. What kind of triangle is that picture? A right triangle. And we have the side. What is this side directly across from the right angle, Carl? It starts with an H. Hypotenuse, yes. So the tip is, in your right triangles, the hypotenuse will always be the longest side, okay? Because 90 is as big as it's going to get in a right triangle. So therefore, the hypotenuse will always be the longest side. I want you guys to try that last example. Look at your picture. Read the little paragraph that is given you. During a game of paintball, opposing teams try to eliminate players on the opposite team. Manny and Lynn are on the same team and want to eliminate Logan from the game. If Manny, Lynn, and Logan are located in the positions shown in the diagram, who is close to Logan? Okay, does everybody see your angle measures in there? Find out the angle at Manny first. Then look at your segments. Label them, the short one, the middle one, and the long one, and then you'll be able to see who is the closest to Logan. You can't just look at it and tell. You have to do the math to figure it out. If the angle at Logan is 39 degrees, the angle at Lynn is 76. Figure out what the angle is at Manny. Then you can decide which is the shortest side. What is it I do again to find that missing angle? What do I add? 76 and 39. And then I subtract that from, yep. What's that give me, 65? Okay. So what's my smallest angle? Logan, okay. So the side across from, so the distance between Lynn and Manny is going to be my shortest side, and I'm just going to put an S there. That lets me know which side is the shortest. What's the next angle size? In order, not the largest one, but the middle one. Yep, Manny. So if I'm looking the part across from Manny, and it's hard to see the highlighting here, that is going to be my middle length, so I'm going to put M there. Like small, medium, large, short, middle, long, whatever you want to call it. And so what does that mean? The other side is going to be the longest one, right? Okay. So what we're trying to figure out now is who is closer to Logan. Is Lynn or Manny closer to Logan? Going from Logan to Lynn, what did we label that one as? The medium, right? The middle one. And going from Logan to Manny is the longest one. So who's closer, the middle one or the longest? The middle. So who's closer? Lynn. Everybody get the idea? Not terribly difficult, right? As long as you can pick out the side across from an angle and the